All right, so not on your quiz tomorrow, but on your test that's next week, there's like a multiple choice section. And part of that multiple choice section is just like, what shape is this? And then there's A, B, C, D, and there's 4 shapes. So one of the options is circle, one's parabola, one's ellipse, one's hyperbola. You just have to be able to pick out which one's which. So here's what you need to consider. How many squared terms are there? If there are 2 squared terms, it's definitely not a parabola. But if there's 1, it's got to be a parabola, okay? Are there any negative squared terms? The only shape that we included a negative squared term was a hyperbola, right? We had the subtraction. So then that means it's got to be a hyperbola. Are the coefficients in front of the squared terms the same? Because now that's a circle, okay? So really we're looking at the squared terms. In this first one, there's just one of them, right? It's just y squared. There's no x squared, okay? So by default, this one has to be a parabola. All right? For number 2, there are 2 squared terms, so it's not a parabola. There's a 5x squared and a 5y squared. So there's 2 squared terms, and the coefficients in front of those squared terms are the same, meaning the distance from x and the distance from y will be the same. And so this one's a circle. For C, we've got a 4x squared and an 8y squared. So I've got 2 squared terms. It's definitely not a parabola. It's also not a circle because the number in front of those squared terms is different. This one's going to be an ellipse, right? The distance from x is going to be different than the distance from y, and that's going to give it this oval-like shape. Two squared terms. This one's kind of tricky though, because they have the same coefficient, which might make you think it's a circle, but it's actually a hyperbola. Because of that subtraction there, it's going to make, instead of making the graph come together like a circle, it's going to make it repel like a hyperbola. So this one is a hyperbola. Kind of tricky for that one. All right, and then I'm just, now that you've seen one of these, I'm just going to go through the other ones fairly quickly. So E is a hyperbola because there's a minus 4y squared. F is an ellipse because there's 2 squared terms and they're different coefficients, but they're both positive. Positive 19x squared, positive 4y squared, that's an ellipse. Letter G is tricky because the y squared term's on the other side. So I'd have to move it to the left first. And by moving it to the left, I'd add it, so it actually would become a positive 3y squared. This is an ellipse, not a hyperbola. It's going to become a plus 3y squared over here when I move it to the other side. Same thing with this one. When I move the y squared to the other side, it would be x squared plus y squared equals 121. So it's 2 squared terms. The number in front of the squared terms is the same. That makes this one a circle. Now I has 2 negative terms. Any idea what you think I is? Any guess? 2 squared terms. They're both negative though, and they have the same number in front. It's a circle. You can divide the negative out because they're both negative and they'd be positive. And because they match, it's a circle. If one was positive and one was negative, then it'd be an ellipse. But both directions are doing the same thing. So this one's a circle. Letter J is a parabola. There's only 1 squared term. Letter K is a hyperbola because you have one that's positive and one that's negative. And the last one is also a parabola because there's only 1 squared term. Once you know what the shape is, then you do the complete the square method to try to make it look the way you want it to. This question wasn't asking you to do that. But an open-ended question might say, what shape is this? Okay, now put it in standard form. You don't have to remember standard form. You're going to have a formula sheet that's got all the standard forms on it. You just have to be able to manipulate the equation to make it look like that. So the only standard form we didn't do yet is hyperbola. So we're gonna finish the hyperbola standard form today, and then I'm just gonna give you time to do like quiz review practice. All right, and then your quiz is tomorrow. So seniors, you're not missing anything new in the next 3 classes. Okay, we're doing review, quiz, review, test. So you're missing review and you're missing assessments, but you won't miss any new material. All right, so today, our goal is gonna be to take something that looks like, which one was my hyperbola? K. So take something that looks like K, which is a hyperbola, and make it look like this. It's super similar to how we do it for an ellipse. The only difference between this and an ellipse is the minus sign. And so you'll be factoring out a negative to get that minus sign. Everything else is the same. All right, so in your toolkit on page 9, there are, I believe, 2 examples that we're going to do. All right. So I want to make this look like the standard form of a hyperbola. First thing I'm going to do is I'm going to put my y's with my y's, and I'm putting the y first because it's presented to me first and it's positive. In the standard form of a hyperbola, the minus is the second one. So normally we start with x, but we're going to start with y for this one. All right, and then I've got a minus 9x squared and a plus 54x. And then I'm going to take this minus 161 and add it to this side. And it'll become a positive 161 over there. So I'm just moving the constant to the other side. We did that for an ellipse. That first step is not any different. All right. Now, I need to complete the square, but in order to complete the square, I need y squared, not 16y squared. So I am going to divide each of these by 16 to factor out the 16. And then I'm going to leave space to complete the square. What's the perfect square that goes in that blank? 4. All right. Now, for this part, I'm going to divide out not a 9, but a negative 9, right? Because I want x squared, and if I don't divide out the negative, I'll get negative x squared, right? So if I would just want this to be x squared, I need to factor out a negative 9. So I'm going to divide both of these x terms by a negative 9. So just be careful. This is positive 45 divided by negative 9. Positive by a negative creates a negative here. What's my perfect square? 9. All right, now on this side, I've got a 161. I'm also going to have a 16 times 4 and a negative 9 times 9. Because remember, it's not just 4, it's 16 times 4. And it's not just 9, it's negative 9 times 9. So I'm adding those 2 things to this side of the equation. Everything so far has been the same as the ellipse, except we didn't divide out negatives in ellipse. And we never really subtracted numbers on the side. Technically, we're subtracting 81. You can do plus, like the same format. It's just going to end up ultimately subtracting here. All right, so on this side, if I factor, we bring down the y, we bring down the plus, and divide by 2 squared. We bring down the minus 9. We bring down the minus divided by 2 squared. So what do we get here? 161 plus 16 times 4 plus negative 9 times 9. Was that what it was? Yeah. 144. And then if that's a circle, you're done. You don't have to do any other steps for complete the square for a circle, but for an ellipse and for a hyperbola, this needs to be a 1. And that stuff needs to be a fraction. So the way to get that to happen on both sides is to divide this out. And what I'm doing from here is just 16 divided by 144, math, enter, enter. And 9 divided by, sorry, negative 9, but it doesn't matter. 144, math, enter, enter. So that I'm simplifying that fraction on the other side. So this becomes a 1/9, but I don't need to write the 1. So y plus 2 squared over 9. Instead of writing a negative 1/16, I'm going to put a minus, and then x minus 3 squared over 16. The minus is in the front. That's what's making it a hyperbola. And then equals 1. This is my standard form. The only step that makes this different than an ellipse is the step where you divided out a negative 9. If this was an ellipse, that would have been a plus 9x squared, and you would have divided out a positive 9. That's really the only difference. So I'm going to have you guys try B. Then we'll go over it. And then I'll give you the rest of the class to do some practice for the quiz tomorrow. All right? And this is the last new content of the unit. There's nothing more in the toolkit, I don't think, right? This is the last entry. So you're trying this one.
You have a call from 1200.
Diana, that's for you. You didn't want to learn anything new besides this.
All right,
And then quiz review there. I'm assuming I'm not seeing you anyway, right?
No, I'm going before.
All right, so we'll see you when you get back. Have fun.
Thank you.
Yep.
Have a good day and good weekend.
You too. This one's tricky because it's the negative y squared and there's not a number there, right? So I'm technically dividing out a negative 1. Okay, you do have to divide out the negative, because if you don't, you'll have a negative y squared, and we can't complete the square with a negative y squared. It needs to be positive. So I divided out the negative. I have that plus 8y highlighted because my guess is if you messed up anywhere, it would be having that as a negative instead of a positive, which does not really affect your math. It would affect your center if you were graphing it, but like it wouldn't affect the 24. I think you'd still get 24 if you messed that up. All right, I just have that highlighted because that's a common mistake area for kids, all right? And then I completed my square and factored, divided by 1. So this would be my final answer. X minus 2 squared over 6 minus y plus, you might have minus there if you missed the dividing by the negative 1, plus 4 squared over 24 equals 1. What do we think? We okay with that? All right, so tomorrow your quiz is on ellipse and hyperbolas, which are very similar in a lot of ways and different in a few annoying ways. The way you find C is different. The formula is different. Instead of connecting them in, you're connecting them out, and you have to know if it's up or down or left and right, all right? So you have the rest of class over 40 minutes here to work on the review. I also have a bonus block tomorrow where you're going to review. So there's a lot of time between now and then for you to review for this quiz. The actual quiz review itself is page 15 and 16 of the workbook. That says hyperbola and ellipse quiz review. The answer key to that is on Canvas, but it's also on the backboard if you don't feel like having a laptop out. All right, so it's on the backboard. Some of you on the last quiz said, do you have any more practice? So if you want additional practice outside of 15, 16, there is extra ellipse practice on page 10 and 11. And that hyperbola handout that I said yesterday that I was just going to leave in the front of the room, that's there still. The answer key to all of the above is on the backboard. You let me know if you have questions. Otherwise, the rest of the class is yours to do with it what you will. Quiz tomorrow. Questions?